Hey everyone, this is Darshan Center. In this video, we're going to be talking more about trig and about the unit circle. Now this video may seem a little bit more tedious because it's going to be all the stuff that it's going to be a lot more memorization. I'm just going to introduce you basically the stuff that you need to memorize, okay? So again, like I mentioned, I don't like memorizing, but I'm just going to give you an overview of the basis for what you will be required to memorize, and then in future videos I'll give you a few helpful pointers on how you can memorize this stuff a lot quicker. Okay, so here we go. Let's get started. So just as a warm-up, so I've given you this angle here, and I would like you to try to solve for x and y. Just find what x and y are. So I've given you an angle here, and I'm asking you to find what those coordinates are. So you may be wondering how you do that, but if you actually remember, then the y coordinate is always the sine of the angle, and the x coordinate is always the cosine of the angle. So sine of pi over 8, and by the way, this is in radians, okay? So don't get really confused. This is in, I'm just probably going to write it out there. So this is in radians, because as we progress further into the unit circle, and you're going to see that everything's in radians. So I just want to start getting you used to seeing radians more often. I personally like degrees better, and just because you can actually have a rough idea of what sort of angle a degree is, but radians are what you're gonna see more often than not. So I just want to get you used to looking at this, okay? So sine of pi over 8 is going to be equal to the y coordinate. It's going to be, if you use SOHCAHTOA, then it's opposite over hypotenuse, and remember the hypotenuse is the radius of the circle, which is just going to be 1. So that's just y over 1 or y. The cosine, similarly, the cosine of pi over 8 is again just adjacent over hypotenuse, which is x over 1 or x. And we could solve for these, but we'll need a calculator to do this. So I'm just going to get a calculator out here. And just importantly, before you actually try solving for all of this, before you actually put this into your calculator, make sure your calculator is in radian mode. Just ask yourself, is your calculator in radian mode? Because if you calculate this in degrees, then pi over 8 in degrees, it's basically going to do this. It's going to take pi, which is like 3.14 blah 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 blah, divide that by 8, and this is like approximately it's about 0.39, and it's going to say find the sine of 0.39 degrees, which is obviously, does that look like 0.39 degrees? No. So you don't want that. So whenever you do this, make sure you're doing it in radians, okay? Make sure you're doing it. If you're ever finding the trig functions of an angle in radians, always make sure you do it in radians, okay? And similarly, if you're doing it in degrees, make sure you have your calculator set to degree mode, okay? Just a little pointer there. So because it's kind of annoying to type pi into this, I'm just going to do this in degree mode. And as you notice, my calculator is in degree mode there. But if I wanted to change to radians, I would just hit that button there. If you have a TI-84, then you need to go to mode, and then it's the third option from the top. So if you have a TI, then I think that's how you change it. So I'm just gonna, because I have a degree, because it's rather annoying to type pi into this, I'm just gonna convert this to degrees. So if you remember, the conversion factor between degrees and radians is 180 over pi. These two cancel out. So this is basically 180 divided by 8, which is 22.5 degrees. Okay. And now I can just use degree mode and just solve for that in my calculator. So the sine of, or let's just type that out, 22.5. Oh, whoops. So sine of that is about 0.38. So it's about 0.38. Okay. And the cosine of that is about 0.92. So these are our answers. So again, you'll not see I doubt you'll see examples like this very often, but this forms the basis for what we're gonna do later. So if you are given an angle that you don't know, like a random angle like this, then you would plug into your calculator and you'd get numbers. And I think there are also times when you'd probably, and these are usually answers that teachers hate because they're decimals, and they'll usually ask you for something like √2 or like I don't know, like 16/10 or some stuff like that. So they'll ask you for fractions or radicals. So make sure you'll not see these very often, but just for our purposes, I'm just doing this today, okay? So now let's get on to what I wanted to do today. So that whole process applies when you don't know the trig functions of the given angle. But what if we use an angle that we know? So for example, if I said 30 degrees, which is, by the way, pi/6 radians, and I asked you to find the x comma y of that, what would you do then? Well, you should have the three trig functions of that memorized. So again, I showed you a useful way to do that in one of my previous videos. I explained this. So because it's a special right triangle. Okay, the 30, 60, 90 is a special right triangle. So again, you should just know this. So, and we know that the sine of 30 is basically 1/2, and the cosine of 30 is √3/2. Okay, so I'm just going to erase these. I'm just going to replace x and y with those. So 1/2 2. Again, this is the x coordinate and this is the y coordinate. Okay, so I hope you see what I did. Again, you could draw the triangle and derive this with SOHCAHTOA, but this I just feel is a little bit more easier. It's just memorizing it is probably more efficient for time. Okay, and what other angles do we know the trig functions for? Well, we know 45 degrees, right? So I'm just gonna approximately draw that. So whole thing there is about 45 degrees, and we know that the sine of 45 equals √2/2, which is going to be a y coordinate. And this stuff is just like memorized stuff, so I just know this out of the back of my head. And if you want to recap on how we actually derive this stuff, I've done a video on that, so you can just check that out. And the cosine of 45 is again same thing, 2/2, which is going to be the x. Okay, so I hope you see what we're doing here. We're just basically taking our special right triangles and putting them on the unit circle. This is basically what we're doing right now. Okay, and the last angle that we need to know is that it's really complicating to know rather is this, which is 60 degrees. Oh, and by the way, this is pi/4 radians, and this is pi/3 radians. Okay, so I'm gonna do the things I'm gonna do the calculations in radians for this. So the sine of pi/3, this is, by the way, the same thing as 60, but I'm just showing you in radians so that you have a good idea of what's what. It's gonna be the y coordinate, which is just gonna be, if you remember our rule, then the cosine of 30 is equal to the sine of 60, so that's gonna be √3/2. It's gonna be the y. The cosine of pi/3 is gonna be 1/2, because sine of 30 is cosine of this. It's gonna be x. So again, let's just put those in. Okay, so this is basically all that you need. This is basically the fundamental part of the stuff we're covering today. Okay, so these things you'll be asked to memorize, and you'll need to know it like out of the back of your head. And after this, it's basically this is basically all the new information you need to know. Later you tessellate this over this to this quadrant and over to this quadrant and over to this quadrant, and then the signs will change, and the angle measures will change, but these values, the absolute values of these will remain the same. And then of course we could and if you after you finished all this, like after tessellating everything, you would get something that looks like this. So I got this off wiki images. So you would have all this stuff here, like you'd have 90 pi over 2, which is the coordinate here, and then as you can see, the absolute values of the coordinates are not actually changing, but they're just changing according to the quadrant. So if you remember, on this side, we're on this side of the y-axis, so our x coordinates are all negative. And because we're on this side of the y-axis now, and this side of the x-axis, so both coordinates are negative. And because now we're on this side of the x-axis with this side of the y-axis, because we're down below the y-axis, x-axis, and I'm getting confused here, ain't I? And to the right of the y-axis, the x coordinate is positive and the y is negative. So again, I did an explanation on quadrants in a previous video, so you can go check that out. And again, like I said before, only the angle measures are changing. The actual coordinate values themselves are not changing. So this is something that you'll need to memorize, like as daunting as it may seem, but it's not actually that hard. Like as daunting as it may seem, it's not that bad, but it is a pain in the butt. But all the same, again, you could derive all of this using like triangles, but in my opinion, that just takes too long. So when you're doing tests and quizzes, teachers will just say memorize, and it's probably the most efficient way to study for tests or quizzes. Again, in the long run, knowing how to derive this is good, but for now, it's just best to memorize. So again, this is all the stuff that we derived, and yep, that's about it for this video. I'm gonna make some more videos on how you can actually memorize this stuff a lot easier. Okay, see you later.